All right, today we are diving deep into one of the most critical parts of your computer, the real secret sauce behind its speed and performance. We're talking about RAM. You totally know the feeling, right? You're in the zone, you're working on something important, maybe you've got some music streaming and you have, I don't know, like 50 browser tabs open, and then suddenly everything just grinds to a halt. Well, the culprit behind that frustration, it's usually the very thing we're talking about today. Yep, that's it. The hero that's supposed to swoop in and save your multitasking sanity is your computer's RAM. It is the absolute key to keeping everything running nice and smooth. So let's just get right into it. So what exactly is this stuff? Well, at its very core, RAM is your computer's short-term memory. And honestly, if you can just grasp that one single idea, you're already well on your way to understanding how it all works. So its full name is random access memory, and the best way to think of it is as a high-speed but totally temporary workspace. See, when you open a program or a file, it gets loaded from your slow hard drive into this super fast RAM, so the processor can work with it instantly. But here is the catch. It's temporary. The technical term is volatile, which really just means when you shut down the power, poof, that whole workspace gets wiped clean. The best analogy I've ever heard for this is a workbench. Think about it. Your hard drive, that's like the big tool shed where everything is stored away safely. But RAM? RAM is the actual surface of your workbench. Now, a small bench gets cluttered and messy really fast, right? It forces you to constantly run back to the shed for things. But a bigger bench? Oh, a bigger bench lets you lay out all your tools, all your projects, all at once, making everything you do way more efficient and a whole lot faster. Okay, so this whole workbench idea is great, but how does it actually function on a more technical level? Let's take a look at the actual mechanics behind it. There are really four crucial things you need to know about how RAM works. First, as we said, it's volatile. Power goes off, the memory is gone. That's it. Second, it's incredibly fast. We're talking orders of magnitude faster than even a brand new SSD. Third, it allows for random access, which means the CPU can just jump to any piece of data it needs whenever it needs it instantly. And finally, all of those things combined are what enables multitasking. It's what prevents those frustrating slowdowns when you're juggling a bunch of different applications. But here's where it gets really interesting. Not all RAM is created equal. In the world of computer memory, there are two main players, and they each have very, very different strengths. You can think of the two types like this. You've got SRAM, which is the sprinter, built for just explosive short burst speed. And then you've got DRAM, which is the marathon runner, built for endurance and a whole lot of capacity. Okay, let's dive into our sprinter first, SRAM, or static random access memory. This is the stuff that gives your processor its absolutely lightning fast reflexes. And its complexity is the key. To hold just a single bit of data, a 1 or a 0, SRAM uses a stable little circuit of 6 transistors. Now, because this design is so robust, it doesn't require constant refreshing, and that is the secret to its incredible speed. So because of that 6-transistor structure, SRAM is extremely fast. And like we said, it doesn't need to be refreshed. But that complexity also makes it very expensive and pretty bulky. That means you get a much lower storage capacity. And that's exactly why you don't find gigabytes of SRAM in your computer. Instead, it's used in these tiny, precious amounts as the CPU's cache memory. Think of it like a super fast buffer for the data the CPU needs right this second. Now, let's talk about our marathon runner, DRAM, or dynamic random access memory. This is the workhorse. When you buy a computer that has 8 or 16 or 32 gigabytes of RAM, this is the stuff you're getting. And the contrast with SRAM couldn't be more clear. Instead of 6 transistors, a DRAM cell is elegantly simple. It uses just 1 transistor and 1 tiny little capacitor to hold a single bit of data. This simple design is a classic game of trade-offs. It makes DRAM much, much cheaper and allows manufacturers to pack a huge number of memory cells into a small space. That's what gives it such high capacity. The downside? Well, that tiny capacitor leaks its charge, so it has to be constantly refreshed thousands of times per second, which of course makes it slower than SRAM. But this balance of cost and capacity makes it absolutely perfect for your computer's main memory. So you might be wondering, hey, if SRAM is so much faster, why don't we just build our computers entirely out of it? Well, the answer lies in a really clever system of teamwork. It really all comes down to those trade-offs. SRAM gives you just unmatched speed, but at a very high cost and with low capacity, which makes it perfect for that CPU cache. DRAM, on the other hand, offers massive capacity at a low cost, but at slower speeds, making it the ideal choice for that main memory, workbench.
And here's the crucial point. This isn't a competition, it's a memory hierarchy. The super-fast SRAM cache is always trying to anticipate what the CPU will need next, and it fetches that data from the slower, but much larger, DRAM. This teamwork gives you the absolute best of both worlds, a massive workspace for all your applications with a lightning-fast assistant, making sure the processor almost never has to wait.
You know, this dynamic duo of SRAM and DRAM has powered computing for decades. But as our demands for data and speed continue to just explode with AI, with VR, with everything else, you have to wonder, what new kind of memory is going to emerge to become the next unsung hero of speed? What will that future workbench even look like?